Hello YouTube, I'm at work again. Sorry it's a little dark. Just assume you didn't know I was making YouTube videos while at work, although they're not doing much right now. In this video I wanted to talk about a comparison of the societies of ants to the societies of humans. And I want to do this because there are many interesting parallels. Now, there are many social animals out there. Most of the primates, whales, dolphins, wolves, dogs, lots of kinds of birds, but most of these, their societies never have more than a few individuals, maybe a few dozen, maybe 100. If you talk about baboons, you might get a couple hundred. But with ants, and with also other insect groups, you can have societies of the millions, as you can with humans. And I think that an analysis of ant society can actually be very revealing and also show many of the misconceptions people have about human society. Now, if you look at an ant society, each individual ant has a very, very limited scope of knowledge. They are basically really dumb. They respond mostly to, tactile, sensual things. So if they experience heat, they react. If they experience food or water, they react. If they experience what they perceive as danger, they react, mostly instinctually. They don't have a very wide range of senses. They don't perceive very much of their environment. If you were to draw a radius around what they are actually able of comprehending, it's not very much. And yet they have very ordered societies that work very well. And how is this possible? Well, the way that ants communicate with each other, there's a couple ways. They do little dances and stuff, but the main way is through scent. They produce chemicals, and the varying chemicals are basically indicators of different things. And so, if an ant's walking around on the floor of the forest or whatever, and they come across water, which is of course something the ants need to survive, just like us, and the ant is thirsty, it doesn't have any water, it will drink some or take some, I don't know, it depends on the species, but when it goes back to its nest, it will produce a chemical that indicates water. And so other ants will come across this trail, they're very sensitive to it, and they'll say, hey, this trail leads to water. Likewise, if they come across a bit of food, some danger, perhaps more shelter, and whatever other physical things ants are interested in. And I think to help visualize this, it's good to think of these as colors. So let's say that when an ant's walking around, it runs into, say, a little bit of water, it leaves a scent trail. We can visualize that as a little stream of blue. And other ants will come across this and say, if they're thirsty or if they know that they need water, they will follow this line. And, say the ant follows the line, it finds a water source, it will also lead a trail. So now there'll be actually more chemical there than before, and so instead of just blue, it will be twice as much blue, indicating there's a decent amount of water there. And what will happen is, say it's the water is maybe just a little droplet or something, and it evaporates. An ant is going to follow that trail, see that there's no water, and then it's not going to leave a water trail. It's going to keep going until it finds either more water or something else that it's interested in. And of course, then it will leave different scent patterns for other things it encounters. Say food. Let's say for food it leaves a red trail, and if it ever encountered danger, say it leaves a yellow trail. Now, what this means is, just by looking at the colors and tracing their paths, ants can find a great deal about their environment without really knowing anything. So, you mix a little blue and a little red, you get different shades of purple, and ants are going to know there's water and or food in this direction. And the more ants that find food in a certain area, the more chemical they'll leave, and so there'll be a stronger message, there is food here. So, say there's a ladybug that's been killed. You only get 4 or 5 ants that find any food there, and by the time the 6th ant comes, there isn't any food left, and so you only get these 5 trails. But say instead of a ladybug, there's a dead rabbit, which has, I don't know, tens of thousands, hundreds of thousands the mass of a ladybug. Well, instead of only 5 or 6 trails indicating chemical trails indicating food, there could be tens of thousands of trails, because tens of thousands of ants each repeatedly find this food source, which means that the trail is going to be extremely powerful, and more ants are going to do it. And what eventually happens, people are always amazed, like, how do they spontaneously just know that there's not enough food? Simple. There's no more red chemicals showing up. Then they say, hey, there's no food. Whenever then an ant does find food, it will probably be farther away, and they'll move and they'll follow that trail. And then they can, of course, mix and match. They know when there's food and water, or when there's danger, or whatever. Now, people are amazed by this because everyone knows that ants are dumb, and yet they do all these orderly things, and they don't realize that this is the reason, that there's this emergent knowledge base that no single ant accumulates, no single ant produces, and really no single ant comprehends. They just know, okay, there is food this way, or there is water this way. Now, there is an ant called the queen, and the queen is important because she lays a lot of eggs, but she does not direct society. She does not give orders to the other ants. She does not tell them what to do, except perhaps to the extent that if she needs more nutrients, she'll release a chemical to that effect, and they know they have to do it. But she is not telling them where to find food, where to find water, when to attack, that sort of thing. But since she has this name, the queen, people assume that there's this hierarchy, and that's where the brain is. That's the but a queen ant is just as dumb as all that. Her brain's not any bigger. I don't even know if what they have even counts as a brain. It's just a small cluster of nerves. But if we look at human society, this is parallel. Only humans are a little bit more complicated because they don't only look for food, water, and shelter. They look for other things too, like peace and happiness, fulfillment, love. They also look for those things like food, shelter. And with the ants, how much chemical signal there is going to be based on how much of the resources there and how much the ants want. So, if the ants are already drinking tons of water, they're probably not going to produce lots of chemical trails to every new puddle they find, because they already have plenty of water. If they're thirsty, then they will. And so the strength of the chemical indicators is going to be based on the demand that the ants have for good and the supply that's available. This is, of course, exactly like the price system in economics in human society. Humans don't know all the variables. We don't know about the particulars of copper mines in Central America, or chocolate cocoa production in Ghana, or shipping rates, or dock workers' strikes, in the Dominican Republic, or factory innovations in Shanghai. We don't know any of that stuff, but we know how much a Snickers bar costs, or Coke costs, or how much we get paid. And those are the signals that we have. And yes, we also have something like a queen. We have presidents and governments, and people assume that they are directing all of this when in fact they are not. So I think the only huge difference here is that each human is more intelligent than an entire ant colony, and that they go after more complicated ends sometimes. I guess you could say that. You might argue that ultimately we're only after food and sex and that sort of thing, but I think it's very similar. And the other thing is, let us suppose, for instance, that the queen of the ants actually did become their ruler, that she could tell them, do this, do that. And let's even assume that she's smarter than the average ant. Let's even assume she has human-level intelligence. And let's furthermore assume that rather than be down deep in a hole where she can't really see anything and it's pitch black, let's assume she somehow is way up on top of an ant mound, and she has access to more information and more knowledge than any given ant. Were she to try and direct Antonia, it would be a catastrophe. Because even if she is smarter and wiser and has a better perspective than any one ant, she has a limited perspective. On high on her perch, she can't see behind every tree, around every rock, underneath every leaf. And so, for her to, she is denied all the information that's available, that's created by the millions of ants crawling across the floor of the forest, assuming we're in a forest. Ants don't normally live in forests. But, so, for instance, she could just get it in her head, based on what is perfectly reasonable from her perspective, that there's a lot of food in a certain area, when in fact the food source may already have been depleted. But if she orders all the ants to go there to get food, only to find that there isn't any, she has wasted the labor and the energy of all those ants. And she might be right some of the time, but she's going to get it wrong also. And the fact that she dictates that all the ants go there is going to hurt the ant colony. And she's going to get it wrong enough that eventually she could actually destroy the colony. You know, like if we use that rabbit example, you know, as the rabbit gets consumed, fewer and fewer ants are going to find nourishment there, and the chemical trail is going to dissipate, and less are going to come until there's only a few little bones, and only a couple ants are going there. The queen might still think there's a whole rabbit there and order the entire colony to go. Or there might actually be a rabbit there, and she might have the entire colony go saying we need meat, and neglect for the time being that they really need water at this time, and that more meat isn't going to do them any good because they can't even digest the meat without water. And as long as no ants are getting water, they're again wasting their time. And so, and this is assuming that the queen is vastly superior to all the other ants. Now the thing with human society is government officials are not vastly superior to humans. Sometimes you might say they're above average, but since human society is so complex and far beyond the scope, it's not like an ant colony where, you know, you look 100 yards around, that's the maximum extent. You're talking about a society that literally crosses the entire globe. It literally cannot be seen from one spot. I think that the parallels are interesting. I think that they're there, and I think that it's good to learn about it, because then you can dispossess yourself of the idea that an ant colony is centrally planned by a queen, and equally that human society should be centrally planned by anybody, and usually when people want it centrally planned, they're talking about a state. And of course, that's a really bad idea.